Hi there, this video is going to be going over some of the questions from pre-lab for lab 19, which is the buffer lab. And we're just looking at question 3 here. So question 1 and 2 you can do on your own. Look back at the notes if you need to. So question 3 here, you're asked to find the pKa for the following weak acids. Remember, if you ever forget what pKa is, take a look on your equation sheet, and the pKa is the negative log of the Ka value. And you should find that the pKa ends up being, pretty close to the value of these exponents right there. So if you want to bear with me while I do the first one on my calculator, I'm going to take the negative log of 6.2. I would recommend using the E button on your calculator to avoid error here. 6.2 E 10 negative. I'm going to take the log of it, and it gives me 9.21. So notice how this is 9. I should notice this answer is going to be like within 1 of this exponent right there. So that's a quick way to check if your answer is reasonable. So you want to go through and do that and find the pKa's for all these acids. All right, so let's take a look at 3b. Suppose you want to make a buffered solution that has a pH of 7.6. Which weak acid would be the best to use? So here is why we do part A, is when we are making a buffer solution, we want the pH to be close to the pKa. So ideally, your buffer should be like your pH should be within plus or minus 1 of your pKa value. So if we want my pH to be 7.6, I want to have, an acid that's, pKa is between, like 6.6, 8.6, somewhere as close to 7.6 as possible. So if you look back at your answers from the previous question, you will find that HOCl, hypochlorous acid, has a pKa that is closest to our desired pH. Okay, so that answers this first question. Which weak acid should we use? And then the second part is, to create a buffer, what would you mix that acid with? Well, in order to get a buffer, I need a combination of the weak acid and its conjugate base. So I need to somehow get some of this anion, OCl-, into solution. So what we typically would do here to actually make this buffer is I'd have a solution of my aqueous acid, and I would add maybe some solid sodium hypochlorite. Okay, I'm going to choose a salt that contains the anion, which is the conjugate base. And notice I said sodium hypochlorite because I want my salt to be soluble. So choosing like an alkali metal would be a reasonable option here. So if I mix together hypochlorous acid and sodium hypochlorite, I would end up with a buffer with a pH close to, 7 point something. All right, so C, what if I want to get exactly pH of 7.6? So first thing we want to think about our ratios here. It's kind of a ratio question. So we know that Ka is H plus times A minus over HA. You could also use the Henderson-Hasselbalch equation, but I think this one might be the easier route in this case. So I know my Ka value for HOCl, this is what we chose in part B, is 3.5 times 10 to the negative 8th. Okay, we want my H plus concentration to be 10 to the negative 7.6, and that leaves us A minus over HA. So if we rearrange this and solve, and you'll have to bear with me as I do this on my calculator. So 3.5 E negative 8 divided by 3.5 E negative divided by 10 to the, I'm having a hard time figuring out how to plug this in my calculator, sorry, 7.6. It's a problem with using calculators on our phone. I'm getting, 1.39 A minus over HA, and 3.5 E negative. Doing a quick mental math check here, the pKa of this is 7.46, and notice how I want my pH to be 7.6. So I want my pH to be a little bit higher than the pKa, meaning I want to add a little bit more base than acid, which is what my answer is telling me. So that's kind of I did a quick check to see if my answer is reasonable, and yes it is. I would expect to have more base than acid because my pH is going to be a little bit higher than my pKa. If my acid and base were exactly equal amounts, my pH would equal my pKa. So what that means is I could rearrange this to say my A minus concentration is going to be 1.39 times my HA concentration. And let's think about this right here. I need to have a buffer capacity where my 500 ml solution can handle the addition of at least 0.25 moles of either strong acid or strong base. That means I need to have at least 0.25 moles of my weak acid or weak base per every, 0.5 liters here. So what we're basically saying is that we need our concentration of our A minus and HA to be at least 0.5 molar. So bringing this back down here, what we can say is let's have my HA concentration be 0.5 molar, and then my A minus concentration would be 1.39 times that. So it would be like 0.7 molar. So to make a buffer, I would use hypochlorite, and let's actually call this what it is. So I would have a hypochlorite concentration of 0.5 molar, and I would have a sodium, this is hypochloric acid. Whoops, let me go back here. I would have a hypochlorous acid concentration of 0.5 molar, and I would have a sodium hypochlorite concentration of 0.7 molar. And this is how I'd actually go about practically making this buffer. And this should have a buffer with a pH of 7.6, slightly higher than the pKa of my weak acid, because my weak base component is a little bit more concentrated. All right, 3D should be a straightforward one. If you want to create a buffer with a pH of 9.3, which weak acid would you choose? So the idea behind this is you're looking for one where the pH is similar to the pKa. So you want something with a pKa that is close to 9.3. So you should be able to look back at the table from A to answer this question. Let's see.